Well, hi, good morning, and thanks so much for joining me here in my shop for another day with this radio. Yesterday I did the component replacements, just mostly a bunch of capacitors, you can see here. Today I'm interested in the performance of this radio and trying to get it where it's supposed to be. This is not a radio that's ever going to perform all that well. It's a very, very simple radio. So, something I noticed just before I clicked on the camera, we're going to take a look at it and see what it's all about here in the cabinet. So inside the cabinet, on the bottom, is a diagram. And what caught my eye is how the antenna is shown here. So I'm going to get a close-up camera view of that. We're going to take a look and see what is it saying about the antenna, because all I've got here is a bunch of wire and there may be some more involved here. Okay, let me switch to that camera. It might take me a moment to get this focused properly and also turned around. You know, that's probably good enough right there. So what I'm looking at is the antenna coil. That piece doesn't seem to be around. The spool that the wire is wound on. I'm thinking this probably isn't really a small deal. This is probably significant. What else is on here that we can spot that might be of interest? I'm just looking everything over. No, I don't see anything else here that's of particular interest. So what about that coil spool? Let's see, they've got it. Now, you know what? That could be nothing more than a spool you wind the antenna up on when you're done with the radio to put it away. I don't know. I need some instructions to go with that. Okay. It just leaves more of a mystery here. More of a mystery. So I think one of the first steps here I want to do is go over the schematic. Just go through it quickly and see what hints are on there, and plus there's going to be some alignment instructions to take a look at. Try so you know, keep me in the ballpark of doing this properly. Let's check out the schematic here. So the schematic is coming in 2 pages, and we'll have to flip between them, unfortunately. This is the front end of the radio. And I really want to start with the power supply. So let's flip to the power supply page here. Now, power supply is an overstatement. The power supply really is generators at Niagara Falls. So here's the power coming in. There's no transformer in this radio. Here's all the tubes hooked up in series. Shows you the order. The order is a little bit significant, but I see there's no capacitors, no resistors, nothing funny going on here. You can see they're using the 35W4, and some other tubes are designed for a roughly 7-volt takeoff across one of the heaters here, designed to support a light bulb. So without a transformer, these radios are tricky to come up with some way to power a light bulb, and this is the trick. So lots of stories about this light is used to control the inrush current and things like this, and not a lot of truth to that. Maybe a little wee bit, but not a lot. So let's carry on here. So come up into the radio, there's a B+ wire. And what I want to find out is, how does that wire get connected to the chassis? So I'm looking for a chassis symbol anywhere on this diagram. And I don't C1. So we'll flip to the other part of the schematic. Here we are. Punch here, here. This is the one I'm interested in. So I've replaced this R5. R5 was 270. R5, 2.2 megohms. Is that a 5? R4. There's R5 over there. This isn't a 5. This is a 3. R3. Yeah, 270K. And this big capacitor here, C10.2. So I've replaced that guy. Now there was another one. Could it be this one? That had a resistor parallel. The parallel resistor was around 270 ohms. R4. Yeah, 270 ohms. So this is a cathode biasing resistor, and it's bypass capacitor, so these two have been replaced here. That's good. Let's just follow the signal through the radio here. So it comes in on the antenna, passes through a capacitor. This may be more of a protective capacitor for people. I'm not exactly sure what to say about that. I think I see it right on the radio. C1 looks like a mica. It's a big mica. 150 volt AC withstand. So there's a hint as to what it's there for. 20%. Okay. Small capacitor here. Here we have the antenna coil. It's going to be potentially some kind of resonance through here. I don't think so, though, come to think of it. Well, there would be some kind, but whether it's important to the operation of the radio, I don't think so. It's unadjustable. So I don't think they're trying to resonate the antenna in this part here. I don't think so. This side's different, though. Here we have the main tuning capacitor and its trimmer, and they are going to tune against this coil and provide a resonance in the broadcast band. Then the signal goes through C4. C4 is another tiny ceramic capacitor or something like that. Over to grid number 3. Grid number 1 is the other signal grid in this tube, is getting its feed from the local oscillator. The tuning capacitor ganged to here, two-section capacitor, tunes against this coil. I guess the primary has an effect also, and this is the trimmer for it. And the signal coming out of here is fed to grid 1, and then there needs to be a feedback. So the feedback it's going to be in here somewhere. I think it's here. Way out here after the first IF. No, that can't be feedback coming back. Somehow there's a bit of feedback from the output of the tube here. I just can't spot it to get back into this coil to produce a oscillation. So that's very typical of how these radios operate. Grid 1 on the local oscillator, grid 3 on the incoming signal, and the mixture sent out to the first IF here. 80 volts. 80 volts. Doesn't give the bias voltage here. We won't worry about it. We'll check the 80, make sure that's correct. And here we've got the screen on 6, getting its screen voltage here, 80 volts. So it's 80 volts everywhere. Output of this, if you notice in this, excuse me, a little attack of COVID there. The signal wire is heavied up. See, it's using a heavy black line here to make it easy for your eye to trace the signal through the radio. So it's coming into the grid here, amplified on this tube. And looks like 80, 80 again. 80 is the number. Let's look at the rest of the schematic. Coming out of here onto this diode plate here. So the current flowing in this coil here is rectified, only flowing halfway. The rectified output is fired down through these two resistors. So there's a voltage divider resistors, and I'll bet you R6 is 10 times R7. Maybe the other way around. One of these is 10 times the other. Let's see, R6 and R7. Yeah, I gotta go back to here. R6 and R7. R6, R6, and R7. So you see, there's a ratio of 10 there. Oh, R7, volume control. What? Ooh. R7 is the volume control. Okay, I didn't really notice that. So the rectified signal comes down here. There should be an RF killer. Probably this guy right here is the RF killer, trying to kill the RF that's coming down this way. Often they have more capacitors, but don't see any more here. Signal is then sent, the rectified signal is sent through here. At this point, the DC component can't carry on. So all that's left now is the AC component, which is the audio signal. This is the grid bleeder resistor, there's another word for it. And here we come up to the grid on the triode. So this is the two-purpose tube, dioding the output of the IF, and there's another diode right here. So what's going on is that other diode is just it's doing the same as this one. So it's a dual diode tube, but they're just parallel both diodes, so it's really operating as a one diode tube. So the output from the triode, yikes, well, it's got to come down here, I think, on 7. 35 volts. Very, very low plate voltage here on this tube. Is that really the plate voltage? Yeah, I guess that is the plate voltage. 35 volts. Wow, that's really low. It says here, used on some models. So this is the tone control. I have a tone control, so these should be in there. C23. C23. How big is C23? 0.05, 0.005, so a ceramic. Okay, so I didn't change that one. Back to where we were. So out of the preamp into the output tube, into the grid of the output tube. The output tube gets 106 volts on its plate. The screen is only 80. 80 again. 80, 80, 80. Lots of 80 in here. 80 everywhere but here, basically. Okay. The output signal is fed through the output transformer and off to the speaker right here. And this capacitor C18. What is the value of C18? 0.01. I will have changed that one. And here they've got the rectifier hidden way up here. And they're not showing much hooked up to it, are they? Just the output from the cathode. R14 is probably a, what's it, only 114 volts, eh? R14 is probably a smallish resistor. R13 also. Let's take a look. 13, 2200, 14 is 100. 1 watts. We might want to check these to make sure they're correct. And then there's this 240. That sounds like the cathode resistor R12. Let's see if that's what that is. Come down the cathode. There it is, R12, and it's bypassed C20. I replaced this. Very good. Now there's some interesting notes down here I noticed, but let's take a look at them. All voltage measured to B minus. Chassis ground only, not external. There can be some confusion around what this symbol actually means. There can be lots of confusion, so they're clarifying any confusion by telling you when they use this symbol, it means it's just going to the chassis. It doesn't mean it's actually going to a steel rod in the ground or something like that. Or back to the hydro neutral. Average sensitivity for a 50 milliwatt output. So what you're doing here is you're measuring the output at the speaker. You're controlling the input to the antenna with a signal generator, and trying to make 50 milliwatts come out. And then you're looking at how much voltage that I need on my signal generator to get to the 50 milliwatts. And it's telling you what you should need, these different frequencies and different positions in the circuit. So this is another way of testing to see if the radio is really producing what it needs to produce. In fact, really you would use this to help you hunt down problems. And then down here, this is another interesting note. This is a very professionally done schematic here. So this is a change, the changes that have been made. It's change number 3, but it's the first in the list here, which is kind of interesting. Could be that change number 1 and number 2 were incorporated in a redrawn schematic, which is what we're looking at. And after redrawing it and considering it more, they made more changes, and they started making notes. So what did they change? C19, it looks like 1 microfarad. C21 was 10 at 130 volts. But C22 was 130. Why? C22. Information added. So let's look at these ones here. For C19, this is one of the filter, it was right at the end of the filter capacitor. C19, what are they doing with it there? 1 microfarad. So they might have discovered that these electrolytic capacitors aren't really good at snuffing out RF signals. And so in order to snuff RF, they've put this big capacitor in here. That's my guess. And they probably didn't put it in at first, or they've increased the size or something like that. C19, what is it on the list? C19, 0.1. 0.1. But here it says C19, 1. It looks like 1, but you know, see, you shouldn't write this number. If it's 1, it should be 1.0. If it's 0.1, it should be 0.1 to make it much more difficult to lose the decimal point. So maybe the decimal point's missing on the page here. Copy looks fairly good, but it could be 0.1 here. Who knows? C21 was 10. So C21 is this big thing. It's supposed to be a big thing. C21, let's just take a look back here. C21, 20. Then I've gone and put a 50 in here. C22, 50. I thought there was an 80 in there. Well, you know, it doesn't matter. These aren't terribly critical, as long as they're big enough. Big enough. And there's another note here. Information added to C5 and C12. And you see these triangular symbols. This has got a D in it. That looks like an A, hard to see. Not sure what that is. A, B, C, and D. So we should be able to find these triangles on the schematic, drawing our eye to where the changes were made. But you know what? There's no triangles on this diagram. So that's mysterious to me, how that occurs. I don't know how that would occur. And if we look at the other schematic page, same thing. There are no triangles on here anywhere. There's C12 and C5, and there's no notes, no extra notes written here. So, okay, just trying to make sure I'm not overlooking something, some hint on the schematic that might be critical in the end. And okay, not really. Okay, now there's one more to look at, and that is the I have to go back here. Hold on tight. That is the actual instructions for 5-tube AC operated. It's in French here. It's in French because they were selling this radio in Canada or in Quebec, and you have to have the French in it. Tuning range, intermediate frequency 455, undistorted power output, you know, loud, I don't know what 700 milliwatts mean. Maximum power output 1.1 watts. Power consumption 25 watts. Not much. That's it? Wait a minute. I thought there were more instructions here on... Oh. There is no instructions. You have to wing the alignment process, but that's no problem. It's such a simple radio. 2 IFs to check. Antenna trimmer. Oscillator trimmer. And that's all. Okay, so we'd start with the IF and make sure it's intermediate frequency part of the radio. Okay, well, no reason to look at this anymore from here on. Oh, what's that little image doing up there? I have 2 screens to look at in my shop. You know, I have one right on my computer, then I have a large screen I can look up kind of easily while I'm working. And as I see on the large screen, hello everybody. Hopefully that didn't block too much of your view of the schematic. Oh my gosh, I hope not. But I'm not going to do it over again. This is essentially a live video, and whatever happens, happens. Let's go back to the bench here. Okay, yeah, I sincerely hope that didn't mess up. Okay, talking about messing up, my last video that I posted, something went wrong, and just before I made it public, I noticed 15 minutes of the video was missing. So I had to redo it. So anyway, that'll be coming soon, but that'll be coming already because this is coming later. Yes, time distortions in my shop. So what should we do here? We should turn this guy on. We're going to listen to him for a moment. We're going to hit him with the signal generator and try to just judge the sensitivity very crudely. I mean, just listening to the radio helps you judge it. Let's look at this guy warming up here. Then we are going to experiment with the IF a little bit. We'll feed in the 455 kilohertz signal. We'll check the tuning of these guys, and there's a pair underneath. It has to be done. Can we stand this guy on its side? Sure looks like it. A little top heavy. Let's stand him up this way. It's not going to fall over. And another thing we can do is we can check the voltages, the 80 volts and the 105, and make sure that those are correct, because I don't generally go through and check all the resistors for their values, because it's pretty tricky. They're in the circuit. Kind of let other indications draw me to a bad resistor if there is one. Okay, you get to watch me do some house cleaning here. I think this is mostly from the last radio, but I'm not sure. There we go, radio pieces. That's radio erosion you're seeing right now. There we go. Okay, a little radio, let's get you playing here. We're plugged in. I'm going to go on the dim lights. Switch should be on. Presto. Did that light really flash there? Well, can't quite see it in the camera. I think there was quite a flash out of that light. When you first turn on a radio like this, all the tube heaters are cold and the resistance is quite low. And so there is a rush of current that flows in. That rush of current is going to increase the voltage drop on the heater leg that's being used to drive this light. So I wouldn't be surprised if there's quite a strong flash. And there are those who would tell you if this light's burned out, you need to put another one in there, or that flash, that rush, is pounding mostly on the rectifier filament much harder than necessary. Is that really true? I don't know. Some people argue the resistance of this is low, and so it takes the current, and in the end the tube is saved and the light bulb is wasted. I don't know if any of that's really true. Okay, radio, where are you? There you are. Pick up a station for me. No, it's not going to. So I'm going to clip on an external antenna here. I think I'll pull this wire down. Oh, this is terrible. This is a mostly bare copper wire flopping around on my bench. That's not so good. Yeah, I don't like that. Okay, somebody, anybody. Somebody right there. Very, very poor reception. But it's getting something. So, barely picking anything up here in my shop on its own antenna. It's not even on its own antenna. It's on a big outdoor antenna, in fact. Relative to this radio, it's a big antenna. So I think IF is the first thing to start with. Sounds better when you turn it louder. Okay, so we need to do a couple things here in the shop. It was 455. Okay, we can call that 455. The output from there, we are going to want, there's a couple things we can do here. You know, we can put this right on the antenna. We have a protective device in the line there, but let's add another one. The protective device is just a capacitor, but I'm going to put another one in between here. Yeah, I got to change this wire for sure. This is just not good. Take off the antenna here. These are just a little lower on the bench here. Output here. And ground is going to go on the chassis. Careful now. This is where the shock hazard is just a little high. There we go. Hey, what do you hear? I hear the IF. Good. Now, what we want to do is we want to get some kind of objective measurement going. I have a choice here. I can try to monitor the AVC voltage on a meter, which is usually what I like to do, or I can monitor the audio coming out of the speaker, which is usually what they want you to do. And I think mostly it's because it's easier, safer, and less impactful on the radio's operation to just listen to what's going on the speaker. If you try to pick off the AVC voltage and you do it wrong, you'll disturb the radio. Okay, so we don't want to do it wrong. We want to do it right. I just hate this bare wire over here. Yeah. We're also running it on 103 volts right now, which is a little bit low. Okay. Where to feed in the signal exactly? Oh, I'm already doing that. What am I doing? Okay, hold on. I'm okay. I'm okay. I keep thinking this is a more complicated radio than it really is. Right, we're hooking up the meter here. That's right. Jim, what happened to you there? Kind of disappeared into space. Second ground going on. All the instruments in my shop are case grounded together and grounded to the hydro third prong. That's the safest way to put it. So that shouldn't make any difference doing that. And my meter's driven backwards here. What's happened to it? Zero way off? How did it get way off? Okay, 150. So without looking at the schematic, we're going to go right on these capacitors I installed and see what kind of B plus is developed here. Not very much. That's 70, that's just under 80 volts. And the other terminal here. Okay, that's a little more. That's a, so we've got 110 there. And only 80 left here. So the 100, that sounds perfect. The 110 is on its way to the output tube plate, and the 80 is on its way to everything else. So this is the resistor that's in between there. We've got 100 on one side, 100, and looks good. All looks good. So the right voltages are coming out of the power supply. Now we want to take a look at some of the tubes here and see if they are also generating the correct voltage. Get rid of that little. Okay, moving operating radio. Just get a little closer. That's what I'm doing here. There we go. Be carefully turning it. Okay. So all we're doing now is looking for 80 volts on some prong on every tube. And if there's a nice red wire coming to the tube, there is. No, there isn't. That would be a good hint as to which. So we're just looking. I don't want to use my finger on that. Breaking a rule if I do. Let me, what I'll do is I'll insulate my finger with a 1,000-pound righteous banknote, which I keep handy here for some reason. What's on the back of it here? This is a stamped note. It has another number stamped on here. I can't quite read it. It's in red. 1,000, 1,000, 1,000. Is there a year written on this? Berlin, 21st April, 1910. There we are. This might be worth a fortune, but right now I'm just going to use it as an insulation. What? I can't even remember why I ever brought that in here. Okay, here we go. Steady up. Now the zero's gone up here. What happened there? Did the meter not warm up? Okay. So that's going negative, so that's almost certainly the grid. No. Not wanting to short anything out here. Ooh, anybody see that? I think I saw 70. Oh, we're only at 103 volts. Hold on. Ah, there we are. This will be 80 now. Oh, that'll be the power supply voltages will have gone up also. 80 on the money. just a hair over 80. Excellent, excellent. I mean, the radio's working, so what are the chances there isn't a plate voltage? I mean, that's crazy. So we'll look for it here. We should find on this tube, we should find both a plate and a screen. 80 once, 80 twice. There it is. That's that. Next tube down. It's getting a little awkward here. You know, I'm not even going to do it. I can't put a probe in there safely. Let's go down to the output tube. Oh boy, that's a little tricky too down there. Okay. Save my German money for now. We're going to flip this guy right upside down. Block. Okay. How's this going to help the situation any? I don't know. Rectifier tube there. Well, where's the output tube? Jump. I think this is the output tube right here. I don't know. There's another one here. This is the detector here, I believe. Detector tube. There's the 35. Whoops, whoops, whoops. Yeah, a little tight in here for me. There's the 35 on the plate of that tube. Perfect. Now, output tube, plate and screen. Yay. So that's probably the plate. 110. It wasn't supposed to be 103. 80. There we are. And then the grid voltage, again, you know, getting in there. You know what? It's right here. I think it's right here. Volt scale. 6 volts of bias on this tube. Okay, it's probably fine. That's good. There's nothing wrong here. Nothing wrong here. So we're gonna flip. I want the radio back up for. Let's turn it off. Because I'm going to need it like this. Now, AVC voltage reading. We need to look at the schematic to sort that out. Okay, so the AVC voltage is developed by the diode here, which is rectifying the output of the IF. Combination of rectified RF and the half audio signal comes down here. This wire you see disappearing here is the AVC line going back to control the gain of the earlier tubes in the radio. This is a good spot to clip on. Now let's just jump over to the other schematic. It's the first line above the B minus. Here's the B minus. Here's the first line. So here, sort of a raw AVC voltage out of the detector is coming along. This is a fairly low impedance circuit back here. And if you hooked it up directly to grids, nothing would happen. Grids need high impedance, so this resistor is a fixer for that purpose. It raises the impedance. R5. It's going to be a big guy. Oh, not here. R5's over here. R5 big guy, 2.2 megohms. So the problem here is if you put your voltmeter on this side of R5, like maybe right on a grid, you're getting into a real high impedance circuit, millions of ohms of impedance circuit. And even though your meter is high impedance, it's enough to start disturbing the circuit. So you want to be on the low impedance side of this resistor, which you can find in well, all radios. So that puts us between R6 and R7. R7 is a volume control, so it actually puts us on the input side of the volume control. Very typical place to pick off an AVC voltage safely without disturbing the radio too much. You wouldn't want to pick it off here. I think you're getting too close to all this stuff. So this gives you some isolation. This was 50,000 ohms here. So okay, so we got to find this spot, top of the volume control. That's an easy thing to find also on a radio. Top of the volume control. Okay, top of the volume control, and I need another little isolation capacitor here. Oh, no, you don't want an isolation capacitor for this. No. That won't work. I do need a clip lead. So the tube we're interested in now is the detector tube. The detector tube is this guy out here. And we're trying to get past a 47K resistor. There's a 47 right there. 47K right there. How's it done? It seems to be connected to the correct. Well, we're going for the top of the volume control. Here's the volume control. That's the capacitor taking the audio away from the center terminal. There's a resistor on that center terminal also. Oh, that's not the center. Okay, fooled by the wiring. Fooled by the angle of wiring. Yeah, there's a capacitor coming off the center. And here's a big 2.2. There you are, right there. That's pretty certain. That's absolutely certain. That's ridiculously certain. Okay, go on there. I want the radio operating at this point, and because we want to know if what we're doing is affecting the radio at all. And the objective is that it's not affected. Where'd my meter lead go? So we're expecting a small negative voltage, so I'll flip this to negative, and we're on the 15 volt scale. That's perfectly good. Now listening to that schmozzle, it's a combination of signal coming from the signal generator through the IF and antenna signal. Anything change when I hook this up? No. That's the AVC voltage. As I tune the radio and a stronger or weaker signal comes out of the IF, the voltage that's developing here will change. Now, bearing in mind, I've got this signal coming in. I'm going to take this one off. So now we've got just whatever is making it onto this piece of crap antenna. That's probably the minimum AVC voltage there. Let's just check and see what the zero is on the meter. Good enough. Okay, we'll tune around now. Okay, let's see if we can get a station. Hold on. I forgot to put on this antenna again. So you can see the problem in this shop. There's so much noise in here and in my house. The noises are stronger than the stations. So that sounds like my signal generator, but it's not. Okay, so we're set to go here, tuning the IF. So I'm going to reattach the signal generator, antenna off, outdoor antenna off, signal generator back on. Watch that bare wire flying around. Put my money away. I also keep handy a $1,000 bill. Oh, okay, it's fake. It's fake. Tried passing that once, it just didn't work out. Okay. Now, I'm going to tune the signal generator a little bit back and forth, and we're going to watch that meter and see where the peak occurs. Okay, keep an eye on the meter. Peak occurs there. The frequency, Kenneth, now you know, the frequency is 456 on my counter. That's really 457, 458. It's not off by much, but we don't know that everything's lined up properly. We don't know that. No, we're going to find that out now. I'm going to get my handy little screwdriver here. This is slug tuned, so metal screwdriver shouldn't hurt it. Very tricky getting in there though. So we're going to start on, we want to start on the second IF, the one that's closest to the speaker. And that's the one I was about to do. I'm going to do the bottom first. Get back to German money here. In 1910, even the First World War hadn't even been thought of yet. Here we go. Down, down. Because I'm here, I'm going to do the bottom of the other transformer too. Whoa, careful. Poker screwdriver in there. Okay, watching. Down, down. Okay, now on the top. I can just grab this with my fingers, I think. Down. So this is all tuned correctly. I don't think much is going to happen. How about here? Tuned up perfectly. Nothing to gain there. So the next thing we're going to do is we'll tune the radio to the high end of the band. I wonder what signals are in my shop that are that strong. But something. So we're up around who knows where, 15, somewhere like that. Try to find a quiet spot. Quiet with this signal going into the antenna. Let's get this off. Quiet spot based on the ADC voltage. Okay. Now we're going to match the signal generator to that spot. Just a little bit better. Signal generator to that spot. That spot being 1400. We should hook up the signal generator to the antenna. So the low impedance of the signal generator is, even with this impedance matching box, it's still low enough that you can think the impedance of this wire antenna has got to be, I don't know, thousands of ohms. It's just a wire going to nowhere. So any little additional resistance on the antenna, between the antenna and the chassis, which is what the signal generator is, signal coming down. There we are. Now I want to keep an eye on the meter here. Oh, I've got this guy on low voltage. Give him the works. Okay, we'll max that. We're getting a really good AVC voltage now. But I'm hitting this thing. What am I hitting it with? I'm hitting it with a. This will be considered a very strong signal going to the radio. Okay. What we want to do now is look at the frequency that's coming in and what does the dial say. So the dial would say just a little more than 14, and you know, really that's where it is. It's 1440. So that's good enough, I think. Now there is an adjustment here, an antenna adjustment. Just bear with me, I'm going to look at that diagram myself as soon as I figure out how to get there. Here we are. What I'm doing is I'm trying to make sure I know which slug to turn. Okay, so the antenna coil, antenna trimmer, and oscillator trimmer. So antenna, we're leaving the oscillator trimmer alone. It's a little awkward here. Let's try this. So the oscillator trimmer, wow. Where is it? You know, usually there's a screw right in there. Okay, I need a little more light here. So this wire is going right in front of the screw. There it is. Okay, let's get in there. It's pretty cranked down. Now we want to look back at the meter. You can see it over here. Where's the money? Give me the money. Okay, here we go. Watching the meter. Oh, man. That's down. I need a bigger screwdriver. It's definitely a happy point here. Get my hand in the way. That's the happy point. Now this is the end of the radio that nobody listens to around here. Let's go down to the listening end. Okay, so I'm going to turn it to roughly, that should be about 600 by my reckoning. Let's see what it actually is here. Can I just do this? $600, eh? 455 coming through. What about 600? So it's lower than 600. It's 586, but in terms of adjusting it, maybe there's a mark. You know what? There are marks Take a look at this one. Again, this isn't on the instructions, so I'm not so sure what these marks are. Can I just turn this? So the antenna is shorting against itself here. I think that's something is. Something's a little wonky there. Sometimes on the dial they put marks to show where the alignment should be done. So we look at this radio, and no, I don't think that's an extra mark. And this would be 6, 5.5. What's that? So we got. It's really, you know, these scales are not linear in any way. It's really stretching out at the end here. So is there a chance that that's 5? No, 5 is going to be down here somewhere. So what is that? So that could be a mark showing you where to put this plastic piece when the capacitor is all the way this way. That would appear to be straight up. That would appear to be what they would expect. I don't know. How accurate can this be? Let's tune this back in. So we're tuning in 590. Oh, 5. There's a station right there. So what I want to do is I want to make sure the signal generator and the radio are tuned perfectly together. It's me moving the signal generator. That's AVC generating 9 volts now. That's quite a signal. Let me just knock it back a bit. Now I'm going to twiddle that same adjustment at the low end, even though it's not supposed to be adjusted at the low end, and see if we can't just get a little more out of the radio. I think I'm going to put my hand right in front of the meter. Let's get in there. Quickly. Money, money, money. Yeah, I'm going to get my hands in front of the meter here. Well, we'll do that. Okay, I'm going to block for a minute. Okay, yeah, hand in front of the meter. Can we make that, can we make that meter go up? Can we make the meter visible? So what I'm trying to do is get the radio with as good performance as possible in the area where people listen to stations around here. Okay, here we go. Down, down. So this is it. That's it. Local oscillator doesn't need to be adjusted. I don't think I can get any much benefit out of that, especially without precise instructions. What's this mark? Why would they put this mark here? It sure looks like, you know, 16, 15, 14, 50, 14. Nine, 9, 50, 10. Nah, maybe it's just the 50 mark for the 14. Not going to help me anyway. I don't have any instructions on what to do with it. Son of a gun if I didn't switch cameras. Whoops. Sorry about that. I'm looking at this mark right here. I'm wondering if that's a registration mark, alignment mark. I don't think so, though. No, I don't think any hints are on here. Nothing on the back of this. Okay, really, I'm pretty much done here. Just not much else to do. So let's play the radio on its own, all by its lonesome. I may even carry it to another part of my house just to check it. But it's not going to get any better. It is as good as it's going to get right now. Okay, we'll take off these leads. Take off this and this. Take off that. She's all by herself now. Tip this down. So it could have a weak. It could have a weak tube. Now we should. Let's see how well it's working before I decide to test the tubes. I think if our radio is working fairly well, that is the tube test. Oh, let me hang up the antenna. So we're just working with this piece of wire here. So there's a station at 8:30, really unlikely. 7:40. 680. Most radios can get the 680. 640. 590. Well, that wasn't very good, was it? We'll hook up the big antenna here. I should hook it right here. Oop, that's the wrong side. Well, it used to receive stuff. Wow. Where's all the noise coming from? Something. Probably 680. That's a tough one. It's probably 640. It's probably not going to get much better than that. Canadian radio talking about American politics. Yes, if you're American, and there's a good chance you are, Canadians spend a lot of time watching you. I mean, we're up here looking down, we see you. Okay, let's take a shot at this. We'll look at a couple of tubes in here and see what we can see if some of them are bad, and I doubt that very much.